Have you ever played an automatic runner like Geometry Dash? Today, I'm going to show you how to replicate the basic mechanics of a similar game in Gdevelop. If you aren't familiar with Gdevelop, it's an easy-to-use game engine that allows you to create games in 2D and now 3D without writing a single line of code. I'm Adam, also known as Drummer Who Codes. While you're here, be sure to hit the like button and subscribe to my channel. Now, let's get into making our game. Let's start by creating a new project. I'll call this one Automatic Runner. Let's set the resolution to 1280 by 720 and click the box to optimize for pixel art. Now let's create a few objects. First, we'll create our player object. I'm going to create all of the art for this game using the built-in Piskel editor. I'm a terrible artist, but I'll try my best. Click on Add a New Object and select the Sprite object. Let's name it Player and add an animation. And next we'll click on Create with Piskel. Now let's create our art. I'm going to create a square because that's what the player object is in Geometry Dash. After you create the graphic, add a platformer character behavior to the object. Next, we're going to create a ground object. I'm going to go with a black square with a white border around it. Now let's add a platform behavior to it. Next, I'll create a spike hazard. For this object, we'll create a custom collision mask. The collision mask is an invisible border that emits a signal when the player makes contact with it. Every object that you create comes with a default collision mask. Let's look at the collision mask for the spike object by clicking on Edit Collision Masks. The transparent red area is the collision mask for the spike object. As you can see, it extends far beyond our graphic, which means that the game is going to think that the player has made contact with the spike object when it's still pretty far away. Let's fix that by clicking on Use a Custom Collision Mask, then dragging the points until they more closely fit the shape of the spike graphic. It doesn't have to be pixel perfect, just close enough. Once you have the collision mask where you want it, click Close and Apply. Next, we can start constructing our level. There are no rules set in stone for creating your level, just put down some floor tiles and spikes. You can make placing the objects easier by clicking the grid icon at the top right of the screen and selecting Show Grid. Another useful shortcut is that you can duplicate an instance in the scene by holding the Control key on Windows or Command on Mac and dragging the instance with the mouse. You can also select multiple instances by holding the Shift key and clicking several objects one after the other. Then you can duplicate the entire group. This should be enough for us to test our mechanics. We're going to create one more sprite object for right now, and we'll call this one Hazard. For this graphic, we'll create a red box with the top several pixels empty. Edit the collision mask to include only the red square and not the empty pixels at the top. Click Close and Apply. Just one more thing before we add our events. Create a new group called Obstacles and add every object to it except for the player object. And don't forget to add a player object to the scene, and let's go to the Events tab. Add an event with an empty condition, which means that it will run every frame. For the action, select Center the camera on an object and select the player sprite. Now to program the movement. First, let's add a new event that runs at the beginning of the scene, and for the action, we'll select Ignore Default Controls for the player object. Be sure you change the switch to Yes, as it is set to No by default. Then we'll add a new event. For the condition, we'll select key pressed, and you can pick pretty much any key you want, but I'll choose the spacebar. For the action, select player and then simulate jump key press. We haven't previewed our game yet, so let's go ahead and do that. Experiment with the controls, and you'll notice that none of the keys do anything except for the spacebar, or whatever key you chose in the last step, which causes the player to jump. I'd like the player to be at the bottom of the screen, and it's a bit jarring when the camera moves with the player jump, so let's go ahead and fix that. Go to the event where we centered the camera on the player and delete the action. Go ahead and add a new action. Select Camera Center X position and set it equal to player.x, and don't forget the empty parentheses at the end. This will set it equal to the player object's horizontal position. The layer should be set to base layer, and the camera number should be set to 0, which is the default. Now add a new action to the same event. This time, select Camera Center Y position and set it equal to 400. Hit preview, and now our player object appears near the bottom of the screen, and the camera no longer follows the player object when we hit the jump button. In order to simulate movement, we're going to have the obstacles move to the left while our player stays stationary on the screen. Let's add a new action to the event that triggers at the beginning of the scene. For this event, we'll select the obstacles group and add a force. For speed on the x-axis, put -400, which means that the objects will move to the left at 400 pixels per second. For speed on the y-axis, put 0, and let's make this a permanent force. If we preview now, the player doesn't move until we hit the jump button. But he stops when he touches the ground again. Why isn't the floor moving when the player is touching it? Well, it is, but the player is moving with it, and the camera is staying locked onto the player, which gives the illusion that the player object is standing still. When the player jumps straight up, the floor objects continue moving under the player, which gives the illusion of motion. In order to keep up the illusion of motion, we have to tell the player object to move at a constant force that is equal to, but opposite to, the force that the floor is moving with. If you're having trouble visualizing how this works, imagine someone running on a treadmill with another person standing beside them off the treadmill, filming them with a camera. That's the effect that we're going to create. Create a new event with the condition player is on floor. For the action, we'll select the player object and add a force of 400 on the x-axis and 0 on the y-axis, and be sure to make it a permanent force. As it stands, our game will continue adding a force as long as our player is on the ground, making it go faster and faster and faster. So we'll add another condition called trigger once while true, which ensures that the action only runs one time. We also want to be sure to reset the force and reapply it every time we touch the ground. We also want to be sure that we stop the force whenever we jump and whenever we fall. On the event we just created, let's add another event to stop all forces on the player object, and let's drag this action above where we added the permanent force. Now create two more events with the conditions player is jumping and player is falling. For the action on these events, just select the stop the object action on the player. We don't have to add a force on these events because the ground will continue to move under the player object. If you hit preview, you'll see that everything works pretty well. Next, we need to make it possible to lose the game. Let's go back to the Scene tab. Do you remember the hazard object that we created earlier? We're going to use that object to determine when our player runs into a wall. Let's put a hazard object everywhere that the player can run into a wall. Since we made the collision box lower on the hazard object than on the ground object, the collision will only count if we run into it from the side, but not if we land on a square from the top. Let's go back to the Events tab and program the collision. Add a new event. Select the player object and choose Collision, then select the hazard object. For the action, we'll delete the player object and then change the scene to untitled scene, which is the same scene that we're already on. This will reload the scene from the beginning, allowing the player to try the level again. Let's also hide the red squares from the player. To do that, add a new action at the beginning of the scene to set the opacity of the hazard object to 0. Hit preview, and you'll see that the collision works. It's also really hard, if not impossible, to get through the level. Let's go back to the Scene tab, then go into the Player object, and let's make some changes to the platformer character behavior. As far as I know, there's no real science to good controls, so it takes a lot of trial and error, testing and changing values. I'll give you the values that seem to work for me in this instance. First, let's deselect automatically grab platform ledges without having to move horizontally. Next, change the gravity to 1,650 and the jump speed to 500. We can leave the sustain time at 0.2. Preview the game, and that seems to work a lot better, at least on the level that I've created. Your level might take a little bit more tweaking. If you can't get the values just right, try adjusting the speed that the objects and the player move in the Events tab. Just be sure that the player is moving at an equal but opposite value in relation to the level obstacles. Next, let's make the spikes work. You might be able to figure this out on your own, but I'll go ahead and walk you through it. Back on the Events tab, create a new event and select Player, then Collision, then the Spike object. For the actions, you can just copy and paste the actions from the other collision event that we created. Hit preview and the spikes work. Next, we're going to add some visual flair to our game. I'll start by adding a background. I'm going to use a space background that I downloaded for free from itch.io. I'll add a link in the pinned comment below, and while you're checking it out, be sure to leave me a comment letting me know what you'd like to see in a future tutorial. Let's add a new object and make this one a tiled sprite. Select Choose a File and find one of the backgrounds that we just downloaded. If Gdevelop asks you to copy the file into the project folder, click Yes. Place the new object into the scene and drag it to cover the entire level. Whenever you add a new object instance to the scene, it places it one Z level above the last object placed. This is causing the object that we just placed to appear on top of everything else. To fix that, be sure that the object instance is selected in the scene. Then click the Properties panel and set the Z order to something very low. I'll set mine to -1. That's better. Let's preview. The game looks better already. Next, let's add a particle effect to the player object. Add a new object and select Particles Emitter from the list. Much like controls, I don't know of any tried and true methods for particle emitters besides trial and error, so here are the values that worked for me. I'll set the starting color similar to the player of the sprite object and the end color to white. Change the size to 1 and the minimum emitter force and maximum emitter force to -90 and 0 respectively. After you have your values set, go into the player object and click Edit Points. Set the origin point to the bottom left of the sprite. Next, go to the Events tab and add a new action to the player is on floor condition. Select the particle emitter, then create an object and set the X position to player.x and the Y position to player.y. On the player is jumping event, we'll add an action to delete the particles emitter. Copy and paste the action to the player is falling event. Finally, we'll create a new event with an empty condition, and for the action, we'll change the position of the particle emitter to player.x and player.y. This will ensure that the particle emitter stays locked onto the player's position. The final thing that we'll do is create a goal. Create a new sprite object and create a simple graphic. I'll do a blue square. We'll call it goal and place it at the end of the level. Also, be sure to add the new object to the obstacles group. Next, create one more object. This will be a text object, and we'll call it winning text. Change the size to 150, the color to white, and the initial text to "You win." Back in the Events tab, we'll create a new event that will trigger when the player collides with the goal object. For the actions, we'll stop all forces on the player object and on the obstacles group. Add another action to the event. Select winning text and create an object at 0 on the x-axis and 250 on the y-axis. Preview the game and that looks pretty good. We now have the basic functionality for the game in place, but what else can you do with it? The obvious feature to add is extra levels. Maybe you could add some extra visual flair, such as a scrolling background or more particle effects. Of course, we could also use some music and sound effects. Check out my Auto Battler tutorial for an easy way to add sound effects to your game. As always, feel free to take this project and use it as a template for your own games. See what you can come up with, and be sure to send me your finished projects. Also, you can leave me a note in the comments if there's anything that you would like to see in a future tutorial. Thank you for watching till the end, and I'll see you in the next one.